Okay, so picking up where we left off, let's look at another one of these. Okay, so I have y equals negative parentheses x plus 2 quantity squared plus 4. And so you'll notice we switch from function notation to y equals. Sometimes we'll just switch back and forth just to kind of remind ourselves that those both represent the same thing. So remember the vertex on the last one. So it's going to be the x value is the opposite of this. So it would be a negative 2. And then that would result in the 4 right there. Because what happens is when you plug in negative 2 right there, this goes to 0. This goes to 0. So then y would have to equal 4 right there. So when I plug in the opposite of what's right here for x, negative 2 plus 2 is 0. 0 squared is 0. Negative 0 is just 0. 0 plus 4, there we go. That's where that 4 comes from for the y value of the vertex. Now, this time my a value is going to equal negative 1. I've got that negative out in front of the parentheses. There's an understood 1 right there. So what that means is that it's going to open downward. So it's going to open down, okay? And so my vertex is actually the highest point on the graph. So at negative 2 up 4, right there, there's where my vertex is at. And so the graph is going to open down. So I need to go ahead and find my x-intercepts, and that would probably help me go ahead and finish off the graph. And then also my axis of symmetry is just going to be x equals the x value from the vertex right there. And now let's go ahead and find those x-intercepts. So for x-intercepts, by definition, we're going to go ahead and let y equal 0. Okay. So let's see, we're going to have 0 equals negative x plus 2 squared and then plus 4. And so what I'm going to do here is I'm basically going to add x plus 2 squared to both sides. And so that will turn this to a positive on the left side. So, I'm going to add, let's try to color code this a little bit. So I'm going to add x plus 2 squared. So then I have to add x plus 2 squared to the other side. And so what's going to happen here is on the left side, I'll have a positive x plus 2 squared. And then on the right side, what's happening is that's canceling out right there, the negative x plus 2 squared and the plus x plus 2 squared. Then I'm just left with this positive 4, so I'm going to put a 4 right there. And then now I'm ready to use the square root property. So I'm going to square root both sides, and I have to put the plus or minus with the constant. So then we nullify the square power, and so I'm left with x plus 2 is equal to plus or minus, and then the square root of 4 is a 2. And then now I need to go ahead and isolate the x, so I'm going to subtract 2 from both sides, and on the right side, I'm just going to kind of sneak it in right after the equal sign. So I'm going to have x equals negative 2 plus or minus 2. And then now I need to go ahead and look at it both ways. I need to look at it as a plus and a minus. So negative 2 plus 2 or negative 2 minus 2. And so let's see, the first one will give me a 0, and the second one will give me negative 4. And so that's where either one of those values would cause my y value to equal 0. So that's why my x-intercepts are right here at 0 and at negative 4 right there. There's my two x-intercepts. And then we're going to list them as ordered pairs right here. So negative 4, 0, and then comma 0, 0. Well, I can already see where my y-intercept is. It's right there at the origin where that x-intercept's at. So I'm going to have a y-intercept at 0, 0 also. And if you want to algebraically, if you want to find the y-intercept, you could let x equal 0, but you'll see that that's what would come out of that. So now I'm going to go ahead and draw this. So when you're doing your homework, click the vertex for your first point, and then select either the x-intercepts, and that should populate the graph for you when you're doing your homework. So there we go, good enough. And then the range, this time I top out I'm maxing out at 4 and go down indefinitely. So I got to put the negative infinity first, though. And then I'm going to top out at 4, and then I want to bracket that 4 in right there. All right, let's see. I think I have maybe one more of these. Let's go ahead and try this one. So my vertex once again, so I'm going to do the opposite of this, which would be a positive 2. And then that would result in 3 right there. Because if I plug in a 2 for x, 2 minus 2 is 0. This whole thing would go to 0. And then I'd be left with 3 as my return value, my y value. Okay, my a value in this case is going to be a 1. So that means I'm going to open up. Interesting. So my vertex is at over 2, up 3, and I'm going to open up. Interesting. Okay. Well, the axis of symmetry is going to be at x equals 2. It's always x equals the x value from the vertex. So what's interesting about this is it opens up. So that means I'm not going to have any x-intercepts. But let's just assume for a moment, maybe we didn't realize that, and we just want to continue going. So I want to show you what's going to happen if you try to find it algebraically. So for the x-intercepts, we would let y equal 0, or in this case, f of x, right? So we're going to replace f of x with 0. So we're going to have 0 equals x minus 2 squared plus 3. And then we would subtract 3 from both sides. So we'd end up with negative 3 equals x minus 2 squared. And so if you tried to do the square root property, what would happen here is you would get that I. You would get I square root of 3. Well, how am I going to graph a number with the I in there? And so that's just a completely different topic. That would be something you would deal with in another course. So and it's a completely different graph. You don't use the Cartesian plane for that. So we basically at this point, we just don't have any x-intercepts for the Cartesian plane. So we're just going to say none. Okay. On your homework, you might put does not exist. Okay. All right. Now for y-intercept, we will always have a y-intercept. So by definition, for a y-intercept, we'll go ahead and let x equal 0. So I want to go ahead and do f of 0. So let's see, we're going to have 0 minus 2 squared and then plus 3. So 0 minus 2, that's going to be negative 2, but then I need to square that. And when I square that, I end up getting a positive 4 plus 3. Well, 4 plus 3 is 7. So I'm going to hit the y-axis right up here at 7. And so that would be at 0, 7 right there. And then when you're doing your homework, you only need those 2 points and it will populate the whole graph. But since I'm doing this by hand, what I'm going to do here is I'm going to reflect that point across the axis of symmetry over to here to find another point, just to kind of help me as I'm drawing my graph. So here we go, coming down, then come back up. And there we are. And then for my range, let's see, our lowest point is going to be 3. And then we go up and don't stop. So infinity. All right. So now that was going back to looking at this. This was our standard form right here. Sometimes it's referred to as the vertex form because you can find the vertex fairly easily, right? So this next method we're going to look at is if we're in general form. And so that's going to be the one we're a little bit more familiar with, that we're kind of deal with whenever we're factoring or doing the quadratic formula, stuff like that. And so there's a pretty interesting formula that we're going to use here, and it's actually part of the quadratic formula, actually. So you remember negative b. Let me write this down. Let me give myself a little bit of space. All right, so here's the quadratic formula. And so if you remember, for the vertex, whether it opens down or opens up, whether you have a maximum or minimum, it's the highest or lowest point. So here, when you add or subtract, it's causing you to kind of branch out from the vertex, right? That's what happens here. It branches out from the vertex, whether do you do the plus, do the minus, it branches out and you get those other points to create your parabola. So the x value of the vertex is actually just going to be this first part right here, negative b divided by 2a, and I have that written right here. So when given a parabola equation in general form, you can find the x value of the vertex by the following expression, negative b divided by 2a. Once you have the x value, just plug it into the function to find the y value of the vertex. So once you know x, just plug it in, and you can figure out its partner, the y value. Note, the a value in general form still determines the direction of the parabola. So that a value is right in front of x squared right there. So that will still tell us whether the parabola is going to open up or down. So here are the directions. So for the quadratic function given, state the vertex, how it opens, axis of symmetry, and intercepts. So same thing as the other format that we were working with. We'll give the range. Once again, the domain is going to be from negative to positive infinity for all of them. Okay, so starting here, this is going to be my A, this is my B, and this is my C. And I just need the A and the B value in order to use this right here to find the x value of the vertex. So for the vertex, the x value is negative b over 2a, and then the y value, you're going to plug that, whatever that is, you're going to plug that into the function, and that will find the y value for us. All right, so here we go. So x equals negative, and then my b value is a 6, divided by 2 times my a value, which is a 1. And so this becomes negative 6 over 2, which is negative 3. So I figured out the x value is negative 3. Now what I'm going to do is plug that into the function. So f of negative 3 is equal to negative 3 squared plus 6 times negative 3, and then I have a plus 8 right there. All right, so let's see, negative 3 squared is going to become a positive 9, then plus 6 times negative 3 is negative 18, and then I have that plus 8 right there. And so let's see, 9 plus negative 18 is negative 9, plus a positive 8. That will give me a negative 1 right there. So the y value is going to be negative 1 for my vertex, for the y value of the vertex. So negative 1, 2, 3, and then down 1, there is my vertex. Now, how's it open? Well, that depends on A. Well, A is positive, so it's going to open up. It's going to open up like this. Axis of symmetry, that doesn't change. It's still just x equals the x value from the vertex, and it's just this vertical line right here that cuts right through it. Okay, and then to find the x-intercepts, we're going to do the same thing we did on the other ones. We're going to set it equal to 0, except instead of doing the square root property, we're just going to go ahead and factor it. These should be factorable. So for my x-intercepts, we're going to let f of x equal 0. So let's see, we're left with 0 equals x squared plus 6x plus 8. And as I mentioned, these should be factorable. They shouldn't give us too much trouble. So let's see, what multiplies to give me 8 but add to give me 6? That would be 4 times 2 is 8, and 4 plus 2 is 6. So we're going to factor this into x plus 4 and x plus 2. So if you were to FOIL that, it's the same thing I have up above in blue, but we want to go ahead and finish solving this. So now you take each factor and set them equal to 0. So x plus 4, what would make that equal 0? And then same thing with x plus 2. And so we're going to get -4 as one of my x-intercepts and -2 as my other x-intercept. So at -4, which is right here, and -2, which is right here. And then I'll list those as ordered pairs right here. And the y-intercept. Okay, the y-intercept on these are actually going to be pretty easy. Once again, they're done the same way we did the other ones. You're just going to, by definition, let x equal 0. And so if you let x equal 0, what's going to happen is anything with a variable, anything with x goes to 0. So it's just going to be equal to the c value, your constant right there. So right here, let me write this down. So for the y-intercept, we're going to let x equals 0. And what happens is f of 0, you're going to have 0 squared plus 6 times 0. And then you have that constant on the end, that plus 8. And that's the only thing that's going to survive because those just go away. 0 squared, 0. 6 times 0 is 0. So I'm just left with that 8 right there. So when I let x equal 0, my y value is going to equal 8. So let's go ahead and put that on the graph. So let's see right there, and then I can reflect it across. So it's 3 units away from the axis of symmetry. So I'll go 3 units on the other side to make it a reflection across that line. And I'm ready to go ahead and do a little rough sketch here. Let's see, that doesn't look too bad. And let's see, that will work. And then let's see the range. Let's see, so our lowest y value is going to be -1, and we go up. So we're going to have infinity for our maximum right there. All right. So I have a couple more examples here, but I'm going to go ahead and stop this and start a part 3 video.